Welcome back. This module is going to be on technology, population, and some of the critical implications of that for energy and water. So the theme for this module is to look a little bit at energy and a little bit at water and see what a really quick overview of those two systems tells us about some of the patterns that we should be aware of in this age of the terraformed planet, our Earth. So the first thing is to look at energy consumption. It is no surprise, if you recall last module, that energy consumption tracks economic patterns and population patterns. In other words, you can't just look at population, you can't just look at energy, you can't just look at economics. They're all connected. Without energy, without coal, you would not have had the Industrial Revolution. In fact, some people have argued that there should have been an Industrial Revolution in China 1,000 years before the British Industrial Revolution. But it didn't happen because they didn't have coal reserves that were located where they could easily be used to enhance the production systems that they had. Whereas in the United Kingdom, they had a lot of coal. They were able to use it directly in their mills, produce steam. And that energy source was why the UK was able to have an industrial revolution. Today, it's important to realize, particularly as we get into difficult questions about global warming and other issues, that energy is absolutely critical to a developed society, to a developed economy. And as we grow our economy, energy will continue to grow. This is very important. Any energy policy, any climate change policy that doesn't understand that India, China, Brazil, Indonesia, Mexico, other countries are going to need to use more energy if they're going to achieve the standard of living that they want, is a bankrupt policy. Those countries are going to need energy. And the reason simply is that if you're a low-income society and you manage to work into a high-income society, part of what that does is significantly increase your energy consumption. Now again, looking at energy production and consumption over the last couple of 100 years, this message comes through in a different way. So if we index the use of energy in 1900 as 100, then 100 years before that, we were using about a fifth of the energy that we're using in 1900. However, by 1990, less than 100 years going forward, we're using 15 times the energy. And the reason is that a developed economy requires that kind of energy. Now, the reason that this number is important is not just because it shows that we've grown our energy infrastructure enormously. It's important because tied to this is quality of life and economic impacts and environmental impacts. So energy growth at this scale is a significant reason why the Earth looks the way it does. And that's important to understand. Let's turn to water. Water has exhibited the same kind of growth as energy, but a little less significant. And part of the reason is that most water, even today, is used for irrigation. That's true virtually around the world. So because we have increased the area that we are farming, the use of water is going up. Because, of course, individuals require water, the use of water is going up, but it's not going up as rapidly as energy is. Now, some people say, and I'm sure you've heard this somewhere, that water is the new oil. The implication, of course, is we're running out of oil and we're going to run out of water and we're all going to die. That's just wrong. Water is not the new oil. If I take oil and I convert it to gasoline and you put it in your car and burn it, it comes out as carbon dioxide, carbon monoxide, a few hydrocarbons. It has been fundamentally chemically changed. You can't take what comes out of your tailpipe and just say, okay, I'm going to take a few things out of it and it's going to be oil again. It's not. It's fundamentally changed. But water doesn't change, right? If I use water to irrigate a field in California, that doesn't change the fact it's water. It may mean I have to treat the water to get some of the materials out of it before I drink it, but it's still water. So water is not the new oil. What constrains our use of water is our ability to purify it and to get water of the right quality to the place we want it. Not the fact that we're going to destroy our world resources in terms of water. That's just not going to happen. Now, this is an important point when it comes to things like talking about, for example, Phoenix. And is Phoenix going to have enough water? Well, we might or we might not. But it's a choice. Let's say, for example, that we do develop some drought conditions, that the Colorado River flow begins to go down, and that California, because they have a legal right to the water of the Colorado before Arizona does, begins to pull off more and more of the Colorado River water. Well, that doesn't mean that we run out of water. What it means is we run out of inexpensive water, because we can always put desal plants in, desalinization plants that take seawater, pull the salt out of it, and then produce fresh water. Those are expensive, and they require energy, but the technology is there. So we're not going to run out of water. Water may be more expensive, but that's a choice. So one of the things that technology does is it changes the sort of absolutes that we like to throw around in policy terms. We're going to run out of water. And it changes it to a very different and more subtle question. No, we're not, but we may pay more for it. And if we do, what are the implications of that? Suppose water doubles or triples in price. Well, for the average house in Scottsdale, that's not going to matter too much. They'll pay more, they may be a little unhappy about their first bills, but they have enough money to pay for water because water is relatively inexpensive. For somebody who may not be as rich as the people in Scottsdale, it could be a problem. Expensive water could be difficult. Maybe what you need to do is you need to support them using social systems. And of course, for agriculture, expensive water becomes very problematic because they use so much of it. So the question is not, are we going to run out of water? The question is, if we begin to have to charge more for water because it costs us more to produce water of the quality we need, are we going to be able to do it, and what are the changes that implies? Now notice how that's a much more difficult question. That's a very political question. It's not nearly as simple as saying we're going to run out of water. That's why people like simple answers, but simple answers are not what this world gives you. There's a couple of patterns that water shows that are important to think about because they happen in other areas as well, and it's something you should be aware of as you begin to look at these global systems that we're working with. One is that we have been able to decouple water consumption from economic performance. That is, in the past, what you saw is that water consumption tended to go up with economic improvements. That is to say, if my GDP doubled, the amount of money that my economy was producing doubled, then my consumption of water doubled. But what we see from a chart like this is that we have been able to decouple water consumption from growth in GDP. So that 100 years ago, if my GDP doubled, my consumption of water would double. Now, if my GDP doubles, I can still get by on the same amount of water that I did before. That's a very powerful effect, and we see it in other areas. While we are producing a lot more energy today than we did, say, 100 years ago, we have decarbonized that energy significantly. That is to say that the energy we get produces less carbon as waste. And since most of the carbon that energy systems produce as waste goes into the atmosphere as CO2, that means that we're getting more energy with less impact on the climate. So the effect of being able to implement technology efficiencies is very important in being able to manage these systems. What's in a number like this? Part of it is, for example, the fact that we used to do flood irrigation. That is to say, a farmer would simply flood his or her field with water, and that was very inefficient, particularly in a place like the American Southwest, where a lot of it would evaporate. Now what happens is we have drip irrigation, where the water is delivered directly to the plants. We even have satellite systems that observe the moisture in your fields and tell you where you need to irrigate and where you don't, because you have adequate soil moisture here, but not here. So the technology is enabling us to continue to grow our GDP and continue to support the population we have, but not equivalently having to grow our consumption of, in this case, water.